Hello everyone, this is Rajesh Pichaimani and I'm a solutions architect at Amazon Web Services. In this session, I'm joined with two of my colleagues, Ramesh Chidirala and Pradeep Sridharan, senior solutions architect from my team. Today we are going to talk about Amazon S3 tables. This is a feature that was announced in the reInvent 2024. We are going to use one of the workshop, Amazon S3 tables workshop, provide a quick overview of the contents and walk you through all the details. This is a workshop that we are referring to. To access this workshop, use the QR code in the top right corner of the slide. There are 5 labs in this workshop. It starts with the creation of the table bucket and working with the S3 tables using various AWS services, Athena, Glue, and EMR. And finally, in lab 5, we will go over the table management tasks. Ramesh will be covering lab 1 and 2, which is the table bucket creation, and then performing various DDL and DML operations on the tables using Athena. Pradeep will be covering lab 3 and 4 with the DDL and DML operation on S3 table with EMR and Glue. And finally, I will be covering the table management tasks. Over to you, Ramesh.
Hi, I'm Ramesh Chidirala. Let's walk through the first two labs of this workshop. In the first lab, we will be creating a new S3 table bucket. In the second lab, we will be performing data operations on the bucket using Amazon Athena service. We will also review table snapshots to understand icebergs, time travel feature, and schema evolution. To get started, launch the AWS console in a browser and make sure you're in the correct region. Open Amazon S3 console and select Table Buckets from the menu. Click on Create Table Bucket. On the Create wizard, enter a name that is unique within the account for the region. Please note that unlike general purpose S3 buckets, table buckets do not need to be globally unique. Ensure the Enable Integration checkbox is checked. Click Create to complete the creation of the table bucket. You will now be returned to the Table Buckets page where you can see the newly created bucket. You will also see that the integration with AWS Analytics Services is enabled. Note the S3 ARN as you will need it for subsequent labs. Select the table bucket and click on Create Table with Athena. Enter a namespace name and click Create Namespace. After the namespace is successfully created, select Create Table with Athena. Before we can use Amazon Athena, we need to configure a location to store our query results. Select the Edit Settings tab and click Browse S3. Choose the existing bucket that was created as part of the workshop setup and then click Save. You will be returned to the Query Editor Settings page. Choose the Editor tab and click on the plus sign to add a new query tab. We will now be running some DDL operations like create, alter, drop, and DML operations like select, update, insert on the table. Start by running the create table statement to create a new table in the namespace. One thing to note is Iceberg maintains a complete history of table changes through atomic schema commits. Each modification generates a new snapshot of the table with the updated schema, creating an immutable version of the table state. This innovative approach provides atomic operations and time travel capabilities, enabling users to query historical versions of the table. Here we see the query is successful. Next, we will insert some values into the table and then select those values back to ensure they were inserted as expected. For every query you run, ensure that the query successful message appears in the query results. Next, we'll select and confirm that the values are returned. Now we'll run some DML statements such as updating the sales amount for product category laptop. Here we can see that the laptop sales amount value has been updated as expected. Let's now delete from the table where product category is keyboard. And once this operation is successful, we will select the data back to ensure that data was deleted as expected. Let's now run the following query to list the table operations performed and their corresponding snapshot IDs. Here we can see that the various operations we just performed are being captured as snapshots. To demonstrate the time travel capabilities of Iceberg, copy one of the snapshot ID that doesn't have a parent ID. This snapshot ID corresponds to the insert operation we performed in the above steps. Here we can see this corresponds to the insert command. To demonstrate Iceberg's schema evolution capabilities, run the following alter command by adding a new column, city, to the table. And once this query is successful, let's select the data back from the table. Here we can see the city column. And now we'll run the drop table command to remove the table from the table bucket. This concludes the lab. We've seen how to use Athena to create the S3 table namespace and perform DDL and DML operations, and we also reviewed table snapshots to understand Iceberg's time travel feature and schema evolution. Thanks.
Hi, my name is Pradeep Sridharan, and I'll be walking you through the labs 3 and lab 4 of this workshop. Lab 3 is working with Amazon S3 tables with AWS Glue. We'll be building out a data lake with Glue and S3 tables in this lab. Lab 4 is similar. We'll be building out a data lake with Amazon EMR. Uh, so let's go to the labs. So let's get started with lab 3, working with Amazon S3 tables and AWS Glue. Now, AWS Glue is the serverless ETL service offered by Amazon, and we'll be using Glue today to build out a data lake using Amazon S3 tables. Let's go to the Glue console. And what we'll do is we'll create what is called an ETL job. An ETL job is essentially either a script or a notebook that we can run. Here, if you follow the instruction, you can start a notebook. I have already created one in the interest of time, and so I'll go ahead and start kind of showing you that. So you're at the starting page. Let's go ahead and clear all of this. And if you can see that you'll left with one cell, and this is where we'll kind of start inputting some of the code that we can kind of copy from the workshop instructions. Let's see. Yeah, let's first copy the configuration items and run it. Okay, look like it ran. And the next is essentially what we'll do is uh, we'll create what's called a Spark session, which we'll use to kind of really do a lot of the work. So there is some placeholder value here, which we'll kind of edit. Let's quickly add, I think the region is different. Where is the region? Okay. So we'll use Northern Virginia, use East 1, and that will go again here. We'll also get the ARN of the table. So you can copy directly from here. And sorry. Okay, let's run it. So this is going to kind of create a Spark session. It might take a while. So I'll quickly walk you through the rest of the setup. What you're going to do is we are going to use from here on to create a namespace and a table using Glue, and then load a data set into the table and query the table to show that we can actually kind of access the data, right? So this is our overall steps for the rest of this rest of this lab. Okay, the session has been created. Let's go ahead and create. We'll do some configuration, and you can look at it. We are creating a catalog, a table namespace, and table name. We are just kind of initializing the variables now. I'm going to add uh, a configuration modification here because I already have some names configured, but you don't have to do that. And the rest of the setup will be same for you and me. Let's run. Uh, yeah, right now we are going to read uh, a Parquet file from this place and load it into a data frame. Yeah, the Parquet is loaded. You can see that it's about 1350 records. Let's now create a namespace. Once the namespace is created, our next step would be to create the table. Let's create the table. The table is created successfully. Now we are creating a temporary view for the data frame. And then we are going to load the data into the table. You can see insert into namespace table name, data from new data. So now we have loaded or in the process of loading. Okay, successfully completed. Now we can actually query the table to see if the data is there. Let's see, we are querying and just reading one record. As you can see, the record came back. This is the column names, and this seems to be the data. So successfully came back. So yeah, this concludes our lab. In this lab, we saw how to create a table, namespace, and a table, and with the AWS Glue, and load data and read data from the table. Thank you. Have a good day. Let's start looking at lab 4, working with Amazon S3 tables and Amazon EMR. So EMR is the big data product from Amazon using uh, uh, services like Hadoop and Presto. Now, like Lab 3, when we use Glue, we can also use EMR to build out a data lake, and that's what we'll see in this lab. So let's go ahead and start with opening the EMR console. A cluster should already be created for you. Now, one thing you have to do is you have to allow access to this cluster from your machine for you to access the Jupyter Hub. So let's go ahead and make the change. You have to actually add your IP address to the security group. So if you can go into the properties and network and security, you can find the security group. If you click on it, it'll open a different window. So go ahead and create edit inbound roles. The particular Jupyter Hub is actually 9443. So what you do is that you add my IP. I have already added. That's the reason why, if you say save rules, you're not made any changes, but I think that's because I've already added it once. But once you have done that, you can come back here and uh, you should see that it's in the waiting state. Go into applications and let's open the Jupyter Hub just by clicking on Jupyter Hub. And it should open. If it doesn't uh, open right away, you might have to go through allowing it through the SSL setup, primarily because it's HTTPS, but the certificate names might not match. And then you can log in using the given username and password. Uh, Once you are here, start a new PySpark session, right? This should create uh, a very similar interface like what we did with Glue using a notebook. Let's initiate a Spark configuration with the S3 tables using uh, a session creation. So you can copy that particular piece of code. And again, I think you see a lot of the similar ideas. You may have to create, you have to update the placeholders. US East 1, US East 1. And uh, also, I would like to update the table buckets, and copy the ARN. Sorry. And here, okay. So I can run this. So this will take a couple of minutes. So I'll try and catch you up on what we are going to execute for the next couple of minutes. So obviously it will be very similar to what we did with Glue, but using EMR in this case. So essentially we'll be setting some variables, loading the same Parquet file. Looks like we created the session. Okay, let's continue doing this. Set our variables here. Variable set. Uh, Apparently, okay. Let's just print the variables also. Uh, okay, so let's now read that Parquet data and load it into a data frame. And then we can actually just count the number of record. If you remember last time, it was 1350. Let's see if the count matches. Okay, the count matches. Okay, now we'll have to kind of go through the same process of creating a table space name and creating a table. So we'll first create the variable for the namespace and then actually create the namespace. Okay, so namespace created. Now, okay, now it looks like you have to execute this to show that the namespace is actually created. Yeah, you can see that the demo namespace was created in our last lab and workshop namespace was created in this lab. Now, let's create the tables now. Okay, tables created. Now let's display both the namespace and the name of the table. Alrighty. So this is consistent with the response. So I think, okay, we'll do some more reads. And you can see that the table is currently empty. So let's load the data from the data frame into the table. So I think this is the code. Okay, so the tables are ready to be used. Let's do a count on the table. 1350, which is matches with uh, the count we did earlier. Let's just read a couple of rows from the table to see what kind of data it contains. You can see that, yeah, I think seems to be the column names, and then the two records came back. So you can see that. That's good. So we can also alter the table and add a new column. So let's do that next. So here you can try alter table, add column C underscore flag. Okay, so we're adding a new column called C underscore flag. And then you can describe the table to see if the columns are added. So you can actually see that C underscore flag is added here, right? Well, this concludes our lab. As you can see that the S3 tables is pretty flexible. You can actually build build your data lake using uh, Athena or Glue or EMR. The choice is up to you. Thank you.
This is the last lab of this workshop, which covers the various table management tasks. There are three types of tasks that we will be working today. First is compaction. The second one is snapshot management, and the third one is unreferenced file removal. Compaction refers to combining multiple small files into one single large file. This is to help improve the query performance. In this lab section, we will be going over the default configuration and then make some updates. So going back here in S3 table buckets, we are going to use this table bucket and the table within this table bucket for various configurations. The first one is getting the table maintenance status. As you are seeing here, the various configure status that is run on a periodic basis shows successful results. Second one is getting the table maintenance configuration. Here are some of the configuration default values, the target file size for compaction, and we'll cover this in just a few minutes. After getting these values, we are going to update the configuration. Going back and down, we're going to use the put table maintenance configuration API and use the updated value 64 MB for the target file size. Once this CLI is configured, and we can get back that table maintenance configuration one more time to see the updated value reflected here. Okay. Now, moving on to the second section, snapshot management. The two values that we'll be referencing here is minimum snapshots and maximum snapshot age. This is 1 by default. The number of minimum snapshot is 1, and the age is 120 hours. Once the expiration happens, S3 marks the objects as non-current, and it can be deleted after the number of days in another property called non-current days. The deletion of the non-current objects is permanent and cannot be recovered. Now we will go back to see what's the number of snapshots that's available. To use this, you go back to Athena and use this command. Right now we are seeing there are 1 snapshots. Going back to the Cloud Shell, we are going to update the minimum snapshot time, minimum snapshot as 10 and maximum snapshot age as 120. So this is successful, which means that when we come back and get the configuration, now these 2 values have been updated as mentioned here. Okay. The third management task is unreferenced file removal, which means that these objects are not referenced by any snapshots. And this configuration again is at the table bucket level, which is across all the tables within that bucket. Okay. There are again 2 parameters, the unreferenced days as 3 days and non-current days at 10 days. We are going to use this API call table bucket maintenance configuration. One thing I want to point out is this is a table bucket configuration, and the ones that we used is table configuration, right? Just wanted to point out that. Going back and copying this CLI here, this is a successful update, and now we can go back and use a get value to confirm that our configuration is successfully updated. Okay. So unreferenced days as 3 and the non-current days as 10. So these are the different examples of how to use the different API calls: put table bucket configuration, get table bucket configuration, put table configuration, and get table configuration at different levels to update the default values and for your appropriate use cases. Okay. Now we have successfully completed the lab. Let's go back to the slides to complete the session. Here are the 2 references that we would like to share. The first one is the S3 tables workshop. This is a QR code for that. This contains all the labs that we just covered. The second one is the documentation, the S3 tables documentation, and you can also use the QR code listed here. Finally, we would like to thank you for your time and hope to see you soon. Happy building on AWS.